Hands for a minute. I just want to explain substitution for a moment, please. So green and blue, if I can just grab your pens out of your hands, please. So once you've done 1A and 1B, you're starting to get a bit familiar with expanding stuff and working with letters, which I know is foreign to you. But the only thing you need to notice about letters is that they just replace numbers that we don't know yet. We don't know what their values are, okay? And when you start to get to 1C, they start to tell you, well, if x equals 2 and you had 5x take 7, what does that equal? So they're telling you now, if this unknown is now known that it's a value of 2, what would that sum work out to be? All right? They liken it as this little machine, I suppose, as a bit of a calculator. Like the number 2 goes in the top here. Okay? Then it goes through that formula of 5x takes 7, and it gives you an output, it gives you a value. The reason why we've been expanding and simplifying and expanding and simplifying things like, remember we started with that? How do we simplify that? We said it was, we just take away the multiplication sign, it becomes 9x. Well, when we get 5x takes 7, 5x means what, Beth? Yeah, it could. Yep. What else? It absolutely could. Good work. X plus X plus X plus X plus X. 1, 2, 3, 4, 5. Take 7. It could mean that. Absolutely. Okay. What else could it mean, Jay?
5 times X.
Excellent.
Take 7.
It could mean 5 times X take 7. Okay, it means both of those things. Well done. Then it tells us that our number of x is 2. Okay? So everywhere that we have an x, it's actually the number 2. 2 plus 2 plus 2 plus 2 plus 2 takes 7. Sorry. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, takes 7. The output number is 3, okay? Or 5 times 2 is 10, 10 takes 7. See that the output number still comes to be 3. So Beth's way works, Jake's way works. Either way of them work. Think of this as your little machine, and what this process is called substitution. You just substitute what the unknown is for what it is now known as. Alright, the unknown, oh, it used to be x. Oh, hang on, now they're telling me it's 2. So if I know what the known is now, if I know what x is, I put it into my imaginary calculator, I get my output as being 3. And like I've always said in maths, there's more than one way of doing these solutions. Okay, and Beth and Jake just showed us that there were. If we look at these example 5 here, we can see a more challenging way where we say P equals 4, Q equals -2, and R equals 3. Wherever P is, it's got to equal 4. Okay, there's no P there, so there's no 4 going in there. But there is a Q. That equals -2. So it's into there. The reason why you've done 1A and 1B is it's taught you how to expand and also to simplify some of these problems. That gets replaced by the -2, and the R gets replaced by the 3. 2 times 3. The only thing, guys, to be aware of, okay, is remember that the sign belongs to that which comes after it. The sign belongs to that which comes after it. But that's stuff we've spoken about as well before, haven't we? Yeah. All right. So when you get to that substitution, all it is, you know how at the start you said, I'm sick of these letters are horrible. Well, this is a chance to get rid of those letters. We now know what they are. All right. And this confirms before what we're saying, they were unknown numbers. All right. So some of you into that substitution, think of that calculator process to try and work out the output. Okay. Can I explain that better for anyone?
There's some fraction ones.
Fraction ones, yep. if we go up,
1C, 2.
let's take this one here, P plus R. Let's take this one. Can we do that one? Is that all right, Jack?
Yep.
Yep. So P is going to equal 4. So 4. R is going to equal 2. So it's 4 plus 2 on the top line. And Q is going to be negative 3. So what does that look like? 4 plus 2 is 6 divided by negative 3. The output number, you can either do that on your calculator or you can do it in your head. How many 3's go into 6? 2. And negative and a positive makes a negative. So your answer or your output number is negative 2. Okay, so again, do step by step. How do you eat an elephant? Bit by bit. Okay, is that all right?
Yep.
Yep. Any others? They'll make more sense, I'm sure, when you get there, which some of you are, of course. Okay, so the first thing you're looking at with this substitution is what are the letters, what numbers replace the letters?
4 and negative 3.
Yeah, so 4 is there. The divide doesn't change and the negative 3 replaces the Q. So we get 4 over negative 3. Alright? Now, you could leave it like that, or you could make as an improper fraction. That is an improper fraction. So you could say how many 3's go into 4? 1 with 1 left over. That's negative 1 and 1/3.
So, just can't get it, but then
Yeah.
it's like
Sometimes the simplest ones, Jack, are the hardest to understand, sort of thing.
Does that negative matter about anything, or does that just tell you what the it's going to be?
Well, that's just saying if you got it to a decimal, which you can just do on your calculator there, it's saying the number is negative 1.33. So all that's saying is if this was your number line, 0, negative 1, 1, 2, 3, 4, negative 2, negative 3, that's just saying your number's there, negative 1.33. It's just telling you what any number might be. You know, if there was no negative there, it would have been, well, it's 1.33.
So just do like a normal door. Just
Yeah,
use the negative.
yeah. A positive and a negative makes a negative. Maybe, shall we try it? Just
Yeah.
yeah. Let's just do it. So, F says Q. So we're in here. I'll just highlight this so I can see it quickly. Q is negative 3, so it's 8 times negative 3. Yeah. 8 times negative 3 divided by 2 times, and brackets is 4 plus 2. 4 plus 2. Okay. BEDMAS says brackets, got to do them first. So 8 times negative 3 is negative 24. Yeah, you're right with that. And 2 times doesn't change because we're doing the brackets first. 4 plus 2 is 6. That then becomes negative 24 over 12. How many 12s go into 24? Negative and a positive makes a negative number.
Yeah, I got that.
Yep, all right.
Just do the-
Yeah, that's right.